Welcome you to the Texas Project Seminar Series. I'm Rodney Andrews, the director of the Texas Schools Project, and I'm happy to introduce our speaker today, Dr. Joshua Price. I'm at the University of Texas at Arlington. He's done a lot of work on health, nutrition, and education. And here today, we're here to look at, I think, a very interesting paper on a topic that's received a lot of attention in the media for quite some time. So let's give him a round of applause and look forward to his interesting talk.
Thank you, Rodney, and pleasure to be here with you. So throughout this presentation, if you have any questions, please raise your hand, ask, shoot in. I'd love to get any feedback or any questions that you might have. And so this is looking at student persistence in science, technology, engineering, and math fields. So we refer to these as STEM fields from here on out. And so when we think of the science pipeline, we look at individuals entering this pipeline with the intent to enter occupations in science, technology, and math fields. And so we see in recent years, according to the NSF, is that there's been recent increases, or there's been actually significant increases in the fraction of women and minorities who enter college with the intent to major in a STEM field. But when we look at what happens as they leave college, is that women in the past 10 years have experienced very little growth in the fraction and proportion of women who actually leave college in a STEM field. And when we look at minorities, we actually see, or for some women, there's actually some decline in computer science, mathematics, and engineering fields. When we look at minorities, we actually see some small increases in recent years, but much smaller increases that are leaving as opposed to those that are entering in. So this leads to the question is there a leak in this pipeline? What's happening from the time that they enter college to the time that they're leaving college that's causing them to either drop out of college or another outcome is to change into another field of study? And so looking at just some a nationally representative sample or data set real quick, the beginning post-secondary students longitudinal study brought out by the NCS is following a nationally representative sample from 1995 to 2001. And this is to provide some descriptive statistics as to what does it look like in terms of entrance into college and exit out. And so among those, the initial major of choice, we have 23% of individuals are actually majoring in a STEM field or intend to major in a STEM field, 72% are in a non-STEM field, and 6% are undeclared or undecided into what their major should be. Now when we look at this across gender and race, we see a lot of significant differences. So 33% of men enter college with the intent to major in a STEM field, as opposed to only 14.5% of women, although these numbers have increased in recent years. When we look at race and ethnicity, very similar fractions of these groups that actually enter with the intent to major in a science and math field. And then Asians have a much higher fraction. And so this is enrollment. Now we look at what's happening in terms of retention within these fields. What we see is that in STEM fields, 64.1% of initial STEM majors have either graduated or are still in a STEM major in 2001, so 6 years later. 35.9% of them have changed majors. And this is an important thing is the statistic they present here are conditioning on not dropping out. So we see a lot of transition from STEM fields to non-STEM fields. What you don't see is a lot of transition from non-STEM fields into STEM fields, a much lower fraction of that occurring. Now we see also a lot of differences and heterogeneity across the different fields. So what we see is across mathematics and physical science, we have persistence of 43 and 44% that stay within those same fields, but we have 24 and 28% who are changing to other STEM fields. And then about a quarter to a third of them are actually transferring to non-STEM fields. But when we look at like biological science, engineering, computer science, very few of these individuals are actually changing to other STEM fields. What they're either doing is persisting or changing to non-STEM overall. So it looks like there is some heterogeneity across these different fields, but the big thing to note here is that there's a lot of individuals who start STEM who also change to other STEM fields. And now when we look at actual a degree attainment or what's happening after 6 years, is 26.5% of these individuals actually earn a bachelor's degree in a STEM field among those who initially enter college with the intent to major in a STEM field. So very low in sense success in terms of receiving a bachelor's degree. 10.6% of them earn an associate's degree or a certificate, and then 7.5% of them are still enrolled. Now we look at about a quarter of them change to a non-STEM field, and a little over a quarter actually drop out of college. And the question is what then, as we look at the races, how does this change by race and gender? So this is using a different data set now. So that was a nationally representative data set. Looking at just the state of Ohio, looking at public universities, what we see is that within 3 years of initial enrollment, of individuals who enter college with the intent of majoring in a STEM field, only 50% of individuals who are white, actually remain in a STEM field. But only 29% of black individuals. So either they're dropping out or they're changing to other majors. And when we look at the gender differences, 52% of men stay within a STEM field and 40% of females. So it's this difference that's really kind of we want to be looking at, is why is it that there's such lower rates of persistence among black individuals compared to white and females compared to males? And so you might think of this as, is this just akin to STEM fields? So when we look at initial non-STEM majors, we also see some difference here, is that students who are black have much lower persistence in non-STEM fields. And so you might think that this is a higher likelihood of dropping out, whereas females have a much higher likelihood of persisting in non-STEM majors. And so if you want to look at individuals, so suppose we then condition this on not dropping out, we still see this gap between whites and blacks in STEM fields. We see this gap among males and females in STEM fields, but we really don't see any gap among non-STEM fields. And so here, trying to indicate that it's individuals in STEM fields, there's a lot of racial differences in persistence rates. And this leads to the question as to why that is the case. And so there's a lot of different hypotheses of why it is that underrepresented minorities and females are less likely to persist in STEM fields. So you think of a different hypothesis have been harder grading standards, exposure to new fields, lack of skills of preparation. But the one we're going to focus on with this study and in this presentation, and that didn't work out as well as hoped, is the match of race and gender between student and instructor. So the fact is, if you take a class with an instructor of the same race or same gender, is that going to change your probability or likelihood of persisting in a STEM field? And so the specific question is, and we're going to focus primarily on race, and then the secondary question of gender, and we'll explain why that is the case. And so the question is, why should instructors matter? Why should the race or the gender of the instructor actually matter in terms of a student's decision to persist? When we think of this as in these fields, is that you think of an underrepresentation. So women and minorities are underrepresented in these fields, and that may create obstacles or barriers for them to persist and succeed. So an instructor's response is, suppose an instructor sees students of the same race or gender, they may seek out mentorship opportunities, or they may change their teaching style that might benefit these students. You might also expect a student response in that a student seeks out a mentorship opportunity of an instructor of similar characteristics. They might look at the instructor as a role model. It might increase their self-efficacy, and it might also increase their cognitive engagement. That just by having an instructor like them, they're more likely to participate in, and engage in these classes. And what's interesting is, as we look at kind of what's been done, is these are just a few examples. A lot has been done to promote and retain women and minorities in science and math fields. These are just examples. You have Princeton, Duke, UC Riverside, and National Science Foundation. A lot of focus has been put on to try to, how can we increase the fraction and the percentage representation of women and minorities in STEM fields and keep them in these fields. And what that sets up then is this opportunity of if we increase the number of instructors, might there be an indirect result of actually increasing persistence in these fields as well? And this may actually these policies may actually benefit students and not just faculty.
Hey Josh, do you really think that's indirect? Like you don't think that universities have that in mind when they increase representation of minorities?
So I guess indirect in the sense that these policies are directed to put the faculty in there, and as a result of that comes. So I guess indirect may not be the right word, but it's resulting from having the faculty here is going to be this result. But I think that's absolutely in their mind. At least, so the advanced program at Cornell is focused not just on getting women in science and math fields, but as a result of increasing the female in that. And so there's been really one study which have looked at the effect of having an own race instructor at the college level. And this is by Raskin Bailey. And what they find is just a positive correlation between the proportion of courses taken from an own race instructor and majoring in that subject. And so they're just kind of doing a cross-section analysis. And the question that really should come to mind is there selection going on? Do students seek out these classes of an instructor of the same race or same gender, in this case the same race? And if that's the case, that's really what's driving these results. And so they're very upfront that this is just, we're trying to find this correlation, and we're not trying to identify the actual causal effect. There's been multiple studies which have looked at the effect of an own race instructor in the K through 12 literature. And they find actually positive effects. That having a teacher of the own race increases test scores, learning, likelihood of taking advanced math courses, and a lot of different results here. But the question then is, are these results generalizable to the higher education setting? So we see this in K through 12, but do we expect to see the same results at the college level? Now, there's been three main studies which have looked at the effect of own gender. And I think it's important to point out these three studies each take a different approach in how they try to identify the causal effect. And they find similar findings with some caveats. So you first have this paper by Scott Carroll, Page, and West, and they're using data from the Air Force Academy. And the reason why they use the Air Force Academy is it's actually a very nice identification strategy they have. Students are randomly assigned to classes, teachers are randomly assigned to teach those classes, and they have a department level exam. So the teacher does not determine what's on the exam. And so what's nice is you have random assignments, so there's not any self-selecting into classes, but you can also look at grade performance as an objective measure that the teacher has really no influence except by teaching. So they can't change the exam to their students. And so what's nice that they can look at is look at that match that occurs between gender in the introductory courses, look at the grades they get in that course, grades they get in the subsequent courses, and then actually graduating in STEM fields. What they find is that for having a same gender match is there's no effect on the average female. But when they look at these high ability females, or these females who have an SAT math score above 660, that's when there's a large positive effect. And it's such that this positive effect is large enough that it actually closes the male-female gap in performance. But there's several caveats you want to look at this study. Is first, I think, is the generalizability. It's clear that they have a very good identification strategy at being able to identify that effect, but what other setting could this apply to? And so this is the key, is the types of students that go to the Air Force Academy are very different than might go to a public university. The types of instructors at these academies are also very different than the normal instructor. And so while they have this effect, would the same effect occur at a different setting? Phil Oriopoulos has another paper using data from the University of Toronto. And what they look at is they also look at grades, as well as this other outcome of the number of additional STEM courses taken. And their identification strategy is they argue that the courses students take that first semester is exogenous to the characteristics of the instructor. And so what they look at is, at least in the University of Toronto setting, is when students sign up for courses, they don't know who the instructor of the course is. And as a result, they can't select into courses based on these characteristics of the instructor. And so they go through a couple tables to show that, indeed, they argue that having an instructor doesn't increase the fraction of females in a course, or a female instructor. And what they actually find, though, for the results, is that they actually find a negative effect for female students. Meaning that female students who have their first course taught by a female instructor get lower grades and are less likely to take additional courses in STEM fields. So kind of a counterintuitive result that you might find. Using data from public four-year universities in the state of Ohio, Eric Bettinger and Bridget Long look at the outcomes of taking additional courses and actually majoring in a STEM field. Now, their identification strategy is a little different, is they're able to look at courses taken beyond that first semester. And so they're going to take an instrumental variable approach. Is that they're going to look at term-by-term variation in the proportion of courses taught by a female instructor to predict the likelihood of having a female instructor. And we'll talk about this strategy a little bit more later, as I'm going to use something very similar. And what they find then is that for each additional instructor you have, there's a positive effect of females of taking additional courses in mathematics and geology. But there's a negative effect in biology and physics. And so it's unclear as to why there would be a positive effect in these fields and a negative effect in these fields. So it kind of leads this question as to what's the really true effect. And they actually find there's no effect on all fields in the probability of actually majoring in a STEM field. So this notion of having a female instructor in the classroom will actually increase the outcomes of the students, at least in these studies, isn't shown for the average students. Carroll shows that it's for the top achieving students, but not necessarily on average. So the contribution, the studies which I'm going to talk about today, is going to first extend this analysis that's been done looking at own gender and look at the own race and having this match between race of instructor and try to actually identify the causal effect. The second we're able to do is we're able to look at the outcome of intended major. And so when you think of the outcome of grades, performance, and even so grades and performance, is these might not actually lead to graduating in that field. The outcome we really want is, are you going to graduate? Grades and performance may not lead that. You may get a good grade in that class, but you may choose your major or change majors based on your relative performance. And so if you get a B in a science and math field but get an A in a non-science and math field, you may be more likely to change based on that relative performance. When we look at actual major choices or actual graduation, there's so much that happens from that first time the students show up on campus to the time that they actually graduate. Anywhere from 4 to 6 years occurs there, so there's other things that might happen. So it'd be nice to find a short-term indicator that actually leads us to graduation. So I argue that the intended major is an outcome actually of a lot of interest because it's going to show the student's intent to actually reach that goal of graduating in a STEM field. And we're going to look at two different studies, or compose two different studies to use two different identification strategies. One is we're actually going to have random assignment. We're going to look at a data set where students are actually randomly assigned to classes and such that there's not the selection issue there. We're also then going to use an instrumental variable approach similar to Bettinger and Long to look at when there's not random selection or random assignment, what are the results that we have? Can we control for this selection issue? And so the two data sets which I'm going to talk about today is using institutional data from all public universities in the state of Ohio. And then the second data set is using institutional data from Purdue. Now I have results for this, and I have just some basic descriptive statistics from Purdue, but those should be here forthcoming shortly. So the data from the University of Ohio, the state of Ohio rather. So we have 13 public four-year universities, and we're going to look at those individuals. And we have student course level data for first-time freshmen who enrolled between 1998 and 2002. So we have 5 cohorts of individuals, with about 157,000. And so students who started at a non-public four-year university and transferred in are not included in this data. We're just going to look at these first-time freshmen, as well as, first-time freshmen. And what the uniqueness of this data is we have enrollment data, so we know the demographic and characteristics of the student, their gender, race, ACT score, the state of residence. We have administrative records, so we know what the intended major of the student is each semester in which they are enrolled. And then we have the course level data, so we know which courses the student took, when they took them, as well as who the faculty is of those courses. And we also are able then to combine some human resource data such that we know the observable characteristics of the faculty. We know their rank, we know their race, we know their tenure with the school, and a lot of other information on the faculty. So a very rich data set in which we can then match students who enroll in a course with the instructor of that individual course. And we can use that to look at this match between race and gender.
Do you have evaluation data as well of the faculty?
We do not. And so we try to put in some faculty characteristics in terms of tenure status, tenure track, but in terms of how effective they are as teachers, we don't have that information.
When do students have to declare major?
So in this data, we have, I don't know if the data is they actually have it for the majority of students. I think it's like 83% of students who enter college have an intended major. It may not be their declared major, but they actually fill out of what their intended major is, which actually may be better than to declare, because often a lot of majors you can't officially declare until after your first year or second year.
Do you include students who have both declared or indicated intended major?
Correct.
Are they different when you
So the data doesn't distinguish between officially declared and intended. So it's all combined into one group. But that would actually be very interesting to see. With our Purdue data, I think we might be able to do that because they have intended major that first semester, but they can't officially declare until after their third semester. So here are the student characteristics. Now, one nice thing with Ohio is Eric Benninger does another paper, and he compares these to nationally representative samples. And it turns out the state of Ohio looks like the nation in terms of the full sample, the fraction of students enrolled in higher education. So about 54% of the full sample are females, and then 83% are white, 9.2% are blacks, Asian, other race, and the average ACT score is 22.29. Now when we so Hispanics are in the other race. So this is going to be, so when Bettinger did this was early 2000s, and the number of Hispanics enrolling in college increased dramatically since then. And so that's going to be a lot lower than it currently is right now. When we look at the difference between STEM and non-STEM, so 60% of non-STEM majors are females, as opposed to 34.5%. So a much different fraction among STEM. A similar fraction of whites. We see fewer blacks in STEM fields, a higher fraction of Asians. And then another difference is the ACT score, is that individuals who enter in the STEM field have much higher ACT scores than those who enter non-STEM fields. And the bolded items are those that are significantly different than each other at the 5% level. And so the outcome we're going to look at is persistence. And the way I'm going to define persistence in this case is going to be a very narrow definition of persistence, but one that I feel is going to be a good indicator. Is we're going to look at individuals who initially enter college with the intent to major in a STEM field. So that's going to include math, technology, life and physical science, and engineering. The non-STEM fields are business, communication, education, humanities, social science, and these vocational degrees. And so we're going to define persistence as being still within a STEM major in semester I. So focusing here on the second semester. So if you enter college with the intent to major in a STEM field, are you still in a STEM field that second semester? An additional analysis we're going to look at is, are you still a STEM major after that first year? And what we're going to define is an individual going from starting in a math, technology, transferring to an engineering field, we're going to consider that still a success, is that they're still going to be persisting in a STEM field. This is going to be different than what Eric Bettinger does, is he looks at persisting within that same field. So the overall kind of the important question is, we want women and minority to stay and persist in these STEM occupations. As a result, going from math to engineering isn't necessarily a bad outcome. That's still kind of towards this goal of increasing representation. And so we're going to define, as long as you're within these same majors, this category of STEM majors, we're going to consider that as persisting.
When do you take major courses? Like, I could imagine if you're a chem major and you run into OChem, that might say a lot about whether or not you're going to end up a chemistry major.
So we're just going to be looking at introductory courses. And the reason why we'll show in just a bit is a lot of the transition is going to happen within that first 2 semesters. Is that a lot of individuals change those first 2 semesters, and there's not a lot of transition happening after that first year. And so actually, so here's the cumulative percentage.
So you said that they don't declare until year 3 in most cases, right?
So they don't officially declare, correct.
So there's a chance that I can still take a washout class my sophomore year, right? But
Yes.
you're saying you're seeing more movement before they ever get to that?
Correct.
Before they ever declare?
And this is going to show that movement. So hopefully, I apologize if these numbers are a little small, is we look at, in our sample, so here's the STEM majors. After that first semester, 90.6 of these individuals who intended to major in a STEM field are still intending to major in a STEM field. 6.4% of them are transferring to a non-STEM field, and 3% are dropping out. After that first year of courses, about 3/4 of them are still in a STEM field, 17.6%, and then 10% drop out. And so this is the transition which we're going to look at. So we have a half here, and then by the end of the second year, just over half are persisting. And then after this, it's going to bottom out at 50%. So not a lot of transition happening after that second year. A lot of it, about half of it happening after the first year, and then the next half happening after that second year. So these natural transition periods. So usually oftentimes, so in Ohio, so after the third semester is the Purdue. Ohio, the different schools have different policies of when you actually officially declare a major. Some can do it in the first semester, some can do it later. But we see a lot of transition happening early on. And so at least this question is, so OCHEM's happening here, but it's these first experiences you have in these STEM fields that we might think are more important.
These patterns hold across both race and gender?
We'll actually look at these patterns for race and gender. But this idea of, is actually for race and gender, it's going to be, it's happening here and then persisting at that same rate. And then when we look at non-STEM fields, we see just very little transition into STEM fields. But this might not be surprising as you think of the structure of a STEM field. So if you enter college with an engineering major or intent, is there's very structured of which courses you take each semester. Such that if you try to transfer in after the first year, is you almost have to start from the beginning and then go to college more longer. So you might expect lower rates of transition. And then a little higher dropout rates among non-STEM majors compared to STEM majors. And the question Rodney brings up is, do we see these same transition patterns by race? And so this is looking at just the transition patterns of initial STEM majors. And this is just comparing unconditional means between white students and black students. So we see white students, the first semester everyone is a STEM major. And after by the 7th semester, we have about 50% are still within that major. Among blacks, we see it drop quicker, but then the slope kind of remains the same these past years. So that for black students, the transitions and the differences are really being driven in these first few semesters of college.
Can you discern between dropout and a transfer?
So dropout, so I should mention, so what's nice about this data is that if students transfer within the public system of Ohio, we catch them. So if they start at Cincinnati, or I'm trying to think, like Central State University and then transfer to the Ohio State University, we still have them in our data, which is actually very nice. If they transfer to a private school, we lose them, or if they transfer out of state, we lose them. And so when we see these dropouts, I guess I should be a little more clear, is that they drop out of our data. So this might be they're actually dropping out, or they're transferring to a non-public university.
But if you looked at sort of, do you have academic performance?
So I have semester cumulative GPA.
So if you condition on dropping out and I see the grades are fairly low, then maybe they'll be able to, you can characterize those as really evidence that's consistent with dropping out.
Correct.
As opposed to transfer.
Yeah. So if they're high GPA students dropping out, that's probably going to be a transfer. And I don't know the transfer rates within kind of how it feeds. So is there a lot of transfer going on across public universities in the state of Ohio? That I don't know. Now we look at this male-female, smaller gap than the black-white gap, but we see it also occur quickly and then remain similar slope afterwards. So again, this indication that the transitions and these differences are really being driven in these first few semesters. Now, when we look at these differences between black-white, so it's often argued that it may be just that students who enter college aren't academically prepared to succeed in science and math. These are just rigorous courses, and it may just be that minority students are coming from high schools in which they didn't have the preparation for it. And so this dark line is just this difference in means between blacks and white, but then the other lines, now we're going to control for ACT score. And we see that this drops dramatically, meaning that a lot of this is just being in terms of preparation. That once you control for ACT score, it decreases this gap, but the gap still remains. And so this is for the black-white gap. When we look at females, controlling for ACT score has no effect on that gap. That is still persisting there. So this is indicative a little of prior preparation, of what's going on beforehand before they enter college. Indicating that maybe those individuals who enter the pipeline that are minorities may be different than those that are females. And so the method we're going to use to try to identify the causal effect is first we're going to do a reduced form model. And so we're going to look at the outcome of persistence. Do you persist into the following semester or into the following year? We're going to look at the number of black STEM instructors that you have, as well as the number of STEM courses that you take. So controlling for the number of STEM courses you take, how many of those of the instructors were black. We're going to look at the number of black non-STEM instructors, controlling for the number of non-STEM courses. So the idea here is think of this as being able to, this push and pull is, we want to be able to control for the other instructors you have, and so you're just not following where you have the match. We're also going to include student characteristics, demographic characteristics, faculty, and as well as institutional and cohort fixed effects. And so we have all these individuals here using this reduced form model. So as done in previous studies, we're first going to make this assumption that we're going to focus on that first semester courses that you take. And we're going to make about 27% of individuals who change majors do so after that first semester. So there is some variation in individuals changing after the first semester. And so identification strategy is first look at the faculty-student match. We're going to argue that it's exogenous that first semester, similar to what Hoffman or Oriopoulos did. But the one difference here is in Ohio is there's actually information that students have as they enroll in these courses. So we can actually test to see, is this really a valid assumption? And I'll provide some evidence that it's probably not for this case, that it appears there is selection going on. Students are enrolling in courses with instructors of similar race and gender. And then we're going to instrument, secondly, for the faculty race, following a similar pattern to what Bettinger and Long did. So here's our instrument. So we're going to instrument for the number of black STEM instructors. And the instrument we're going to use is the fraction of STEM courses taught by black faculty, or faculty who are black. And so the key here is that each year, so suppose you're at The Ohio State University, in 1998 there may be a certain fraction of courses taught by black instructors, and in 1999, based on either hirings or firings or whatever it may be, there may be a higher fraction of courses that are taught by black instructors. As a result, your likelihood of having that introductory course taught by a black instructor is much higher in 99 than it was in 98. So we're going to use this variation at the institutional level that's going to predict what the number of black STEM instructors you have. And this variation is really going to be coming from things that are exogenous to the student's decision. So new hires, sabbaticals, job loss, temporary assignments, all things that the university is doing to try to fill the courses that they have to teach. We're also going to control for the total number of black STEM faculty at the school. And this is important to do because it may just be as you're walking down the hall in the science building, you may see more instructors like you. And that may be what's driving the decision or helping influence your decision. So if we control for that, then the variation is really going to be coming from the in-class experience. The second instrument we're going to use is here we're just using the fraction of STEM courses. We're just going to look at the number of black faculty assigned to teach those courses. So two very similar instruments which we hope to get very similar results.
So, what would happen if you believe that the reason that there's variation in faculty representation has something to do with performance, like teaching, or, right, because the tenure process could, hirings and firings could work both ways. You could get hired because of a stellar reputation. You could get fired because of a lack of stellar reputation. And second point, yeah, I just want to hear that.
Yeah, so I think the key here is that we wanted to see where the variation is coming from. So is it that variation is being driven by these less effective teachers not making tenure and therefore not teaching? Or is it that the institution is making a conscious decision to say, let's put our most effective teachers in those introductory courses? And that's not necessarily an issue because we're looking with variation within an institution. And so if that's the institution's policy is let's put our best teachers in those first few years, then we're going to make that assumption that's going to stay constant over this 6-year period. And that's going to be, and that may not be true, but I mean, that's going to be the crux of it is if within an institution over time their policy is changing. And that would be the violation of this. But in terms of if an institution is following a certain pattern and there's just these natural variations in the fraction of courses, then that's going to be able to identify our endogenous variable. And so when we look at just the naive model of kind of doing, just looking at assuming that the first semester courses are exogenous. So we look at overall for all students, having the number of STEM courses taught by a black instructor has really no effect on all the students, no effect on white students, and actually increases the probability of black students persisting by 4.5 percentage points. And so this is a linear probability model. And so it's actually, this is a very positive effect, or a significant effect here, but only at the 10% level. But now the question is, are students selected into courses taught by instructors of similar race? And so this is the table that Hoffman or Oriopoulos proposed in their paper, and what they find is that all these results are insignificant. And they look at this for gender, is that having a female instructor does not increase the fraction of students in that course that are female. And so I try to I first do a naive model looking at the fraction of, the dependent variable is the fraction of students in a course who are black. I then look at defining the instructor as a dummy variable, and having an instructor increases the fraction of courses a lot. And so then I throw out a gamut of fixed effects, institutional, year fixed effects, control for other faculty characteristics in terms of tenure track, status, and all this. I look at only STEM courses, and that effect still persists throughout. Much less, but it still seems that having a black instructor increases the fraction of students in that class who are black. So indicating that there is some selection going on into these courses, that students have this information beforehand and are actually using that to choose their courses. And so therefore, we're going to now use this instrument of the fraction of STEM courses taught by black instructors to instrument for the number of STEM courses taught by a black instructor. So the first stage, a highly significant, very high F statistic, so a very strong instrument. And then what we find is in the second stage is we have really no statistical effect here, no statistical effect for white students, but now a large positive significance for black students.
So I'm curious. It sounds like what you've shown us is a preference among students for same race instructors.
Yes.
And so I guess I'm having trouble reconciling that with the idea that universities would be entirely independent, would act entirely independent of that in faculty hiring or retention decisions. Is that a reasonable concern?
As you bring that up, yeah, I mean, I guess it's a reasonable concern. And the fact that if this is changing over time, over the 6-year period, then that would be a concern, and that would violate this assumption. I guess what I would push on, and I guess as you mentioned, I might want to push less on this, is that this is going to stay within a school, it's going to stay the same throughout this time period. That a school might have these preferences and realize that, and so that variation may be very little.
But if they hire because you do well, or they fire because you do well, that's still in violation. Even if the preference, I guess, if the preferences are the same, but the actions vary, right? So the reason why you show up, it's not that universities vary. It's, you know, when people show up, why do they show up? That you sort of need to hold constant in order for that to be a valid instrument. I don't know.
Yeah, so I guess the one is, I think I might be able to tease that out by looking at just hirings and firings as opposed to just allocation of which teachers are teaching. by you could actually able to match, because we know who the teachers are and who's teaching each semester, and to see is it that one teacher's teaching more sections that first semester, or is that new teachers are entering in? But I guess each of those scenarios would also, this idea that the preferences may stay the same, but the actions are what's really changing.
And think carefully about especially with first, if you're worried about retention, you want to put your best your best pedagogical representatives up front. How does that, so it's not that the university preferences remain constant, it's that if you find out that a new teacher is really good and then you move them up front, what does this say about your results, right?
Correct.
Yeah, so I guess you bring up a very interesting point, and I guess I would counter it by, that's what we're going to do, this Purdue data, to actually see what the selection is and see are our instruments really valid. Because so I've made this assertion here, and I'm starting to think about it, and as you mentioned, is you should be skeptical of it. Bettinger and Long have a similar thing with female, but what's nice is with our Purdue data is we can actually then, we have random assignment, we can actually use this instrument to see is it really identifying and is it really correct. So based on the assumption that this is a good instrument, these are the results we have with this. But one thing also to note is, so this is significant at the 10% level, but it's also very noisy. Like this is just a number that's really big that you should be very skeptical that that's the actual result. I mean, this is saying like a 38.5 percentage point increase in persistence, which I think is unbelievably big. And so the question is, do we see, if we do other specifications of the model, do we see similar results? And then also to really note that this is a noisy measure. And so the next thing we're going to look at is this other instrument of the fraction, or rather we're going to look at rather than the number of black STEM instructors, we're going to look at, do you have at least one? So a lot of the variation is going from 0 to 1. There's just really not a lot of instructors who are black who are teaching STEM courses in this data set. And so are you just having one? And again, we see no results for white students, but then these positive but really large results for black students. But it's still a very noisy measure. And so then we're going to kind of go on to use a second instrument of looking at the number of black instructors assigned to introductory courses. Before we were looking at the fraction of introductory courses taught by a black instructor. Now we're just going to look at the number. And again, we see this very large, marginally significant result. And if we do another specification of having at least one STEM instructor, we see the same thing. And so kind of the result, the conclusion I'd like to draw from this is that there appears to be a positive effect. How large that effect is, it's hard to pin that down. But it appears that by having a black instructor in these introductory STEM courses, black students are more likely to persist in a STEM field than if they had that course taught by a white instructor.
I want to push back against my own comment is, I know as an economist, we get hung up on identification, right? So part of the story, it's something's there, right? And what identification tries to buy you, it's what's moving it, right? So, you can provide, convincing evidence that this might not be just an artifact of the data, that there's something real. It just makes it difficult to say, what the mechanism is. So, just because we can't say, instruments are great doesn't mean that we don't learn something from this exercise.
And
right?
you mentioned that, it brings to mind the idea here is that it may just be that having black instructors teach the introductory courses, and then students will self-select into the right courses, and therefore they're more likely to persist. So it's not that the instructor is causing that effect, but by having them there, students can select and then lead to better outcomes. That still leads to the right policy conclusion of having more instructors that first semester can have positive effects on students, if it's being driven by student selection or by the actual instructor's race, or the match that occurs.
If I understand your comment, you're questioning whether it's race or whether or not they're effective at pedagogy.
Right, and that's sort of what it's.
And maybe they're
Yeah.
self-selecting on pedagogy, not on race.
Right.
Correct. And that's the earlier comments, do we have kind of the evaluations of the teachers? And that would be ideal to have. And I'm curious, Purdue data, we might be able to get at some of that. Because it's a single institution, we're working with their office there, is we might be able to get at some measure of effectiveness of teacher or of teaching quality.
Well, is it current data or relatively current data?
Relatively, yes.
So that's, if you've got names,
You would wish that were the case. Our experience currently, and the reason we don't have the data now is even if you have names, to have them information on file is not guaranteed. And so we're running difficulty. We have names, but we are trying to get the characteristics of the instructors. And that becomes a little more difficult. Is there 2 separate files, and we're trying to get the admissions department to merge them. Okay, so here's kind of is among initial STEM majors, it appears to be this positive effect for having a same race instructor for black students. It's consistent across other specifications, but the size of the effect I think is hard to nail down. It's very noisy, but it appears to be positive. And there's really no effect for white students. So this idea of there's a paper in K-12 that white students respond worse by having a black instructor, and that doesn't appear to be the case here. So this is benefiting black students without harming the white students in the course. Now, when we look at female students, we're going to do the same similar analysis for female. And we're going to make the assumption of, does having that match occur in STEM courses? What's the probability of persisting? And this is just looking at assuming the first semester is exogenous. We actually find a negative effect, that females are less likely to persist by having that female instructor the first semester. But then we're going to follow the similar argument that Oreopoulos proposes, is do females select into courses taught by female instructors? And it appears that while it's much less magnitude than we saw with the black students, that still having a female instructor increases the fraction of students in the class who are female, leading us to believe that there is a selection issue. So if we control for that selection issue, what happens?
And why do you think your results are different in terms of significance? I mean,
so I think right here is, in Toronto, it's a unique setting. The way that students register for classes is they don't have the instructor's name or characteristics. In Ohio, they might in some of the scenarios. So I haven't looked to see if all, but like at The Ohio State University is you sign up for a class, you're signing up Biology 101 taught by Professor Smith. And so if you want to, you can look who is Professor Smith.
right, which is exactly what I think does.
Absolutely. Yeah. They argue in Toronto that that doesn't occur because you just sign up for Biology 101 with Professor to be announced. And there's a lot of those, it's harder to find information on professors that way. So, but as a result, if we control for the selection, again, we have very strong first stage statistics, is that effect drops away and is insignificant and really very close to 0 as well. Meaning that there's no effect for female students for having this match occur of female instructors. And if we look at different specifications, it changes in sign, but really it gets a little noisy, but not statistically significant. So similar to kind of the conclusion we want to draw here is that there's really no effect for female students who have a STEM course taught by a female instructor. And so some of the conclusions, so I didn't report these statistics, but it's consistent across boards. Students with higher ACT scores are much more likely to persist, which should come as no surprise. There is suggestive evidence that students are self-selecting their courses based on faculty characteristics, which might think that then selection is something you need to deal with. So what we find is positive effects for own-race instructor of STEM majors, and then really no statistical effects for females. And now this leads us to this next data set we're going to look at is Purdue University. And the reason why we want to use Purdue University is that prior to the fall of 2008, students were randomly assigned to sections within a course. So a student would meet with their academic advisor, and they would say, I want to take Biology 101, Math 101, and just tell which courses they want. Not at what times, but just which courses they want to enroll. They then put it into this computer, and then Watson spits it around, and they spit out the student's schedule. So the student can put preferences of when they want to take classes, but that may not fit into the algorithm. So it's really just this random process. You tell what courses you want, and it tells you what your schedule is. And so there's really no selection going on with this at all. Beginning in the fall of 2008, they then let students choose their own schedule. And so what's nice is we have random assignment, and then we stop random assignment. And so what this allows us to do is in these years we have random assignment, we can actually test the validity of this instrument of does the fraction of STEM courses being taught by a minority instructor or a female instructor actually correct for the selection issue that you might think is going on. What's also nice is between these two sample periods is we can actually see what is the selection that actually occurs. Do students actually seek out these and find teachers that match them on race and gender?
Intertemporal changes in student characteristics over time. Is the student body at Purdue changing as well, the composition?
We'll have to look at that. We have not looked at that yet. So what's nice about this data is that it's going to match students to courses to instructors. The downside with this is it turns out schools don't keep very accurate records of who they are. So oftentimes they'll say, J. Smith taught Biology 101. And you have no idea if J. Smith taught which sections. And so that's what we're trying to work on right now to get to be able to match the students to the faculty or to the courses. And there also may be more than one J. Smith. And so it's very difficult to do this, and we're working with the Purdue University right now to actually get to be able to make this match. And so I don't have results for this, but we have some descriptive statistics we can talk about. So we have demographic characteristics, and we have the 2006-2010 entering cohorts. And we have them up until this last academic year. And so it's not, unfortunately, we don't follow them for a long period of time, but we do see them in these first few years. And even at Purdue University, we're going to see a lot of the changes across majors are occurring in those first few years as well. And actually, after the third year, very little change is occurring in terms of majors. And so here we have this. So this, important to note, this is only individuals who enrolled at Purdue University with the intent to major in a STEM field, and then looking at them 8 semesters later. If they drop out or transfer, they drop out of our sample. So this is conditioning on still being enrolled or have graduated already. So we see after the second semester, we see the blue line is males. About 95% of males persist in STEM. After this first year, a little over 90% persist. And we start seeing these differences across males and females. The females are less likely to persist. Now, one thing also to note is Purdue may not be nationally representative. It's a very strong engineering program. People go there for engineering and maybe have other observable characteristics that may lead them to persist at much higher rates. So we see after 4 years, persistence is still at 85%, where in the state of Ohio, it was down to 50%. And so very different in terms of students. And you might also think that with the state of Ohio, you have a lot of less selective universities. Purdue might be considered a more selective public university. But we do see these differences across gender differences across those individuals who intend to major in a STEM field. Now, when we look at persistence of initial non-STEM majors, what we find is the opposite problem, is that males are less likely to persist in non-STEM majors. And we try to show here is that we have these differences, and then subsequent work, and I don't have the tables here, is we're trying to identify where are they going. And so these individuals here are actually transferring into STEM majors. But if we don't condition on staying enrolled, are they dropping out at higher rates? So men who intend to major in a social science, do they drop out, do they transfer, or this would show they're actually changing to STEM majors at a much higher rate than females. And so the method we're going to use to look at the Purdue is very similar. We're going to have the race of the student, we're going to have the faculty race, and we're just going to look at this interaction between the two. The outcome we're going to look at is this probability that students persist in the STEM field. It may not be right to look at actual grades in a course because that may be endogenous to the instructor and student match. And we're able to do this for the cohorts who entered 2006-2007. And so for these individuals, we can follow them for 4 years and them for 3 years, but we're going to look at these transitions that occur in the first couple semesters. And by random assignment, delta is identified. Meaning that we can identify the causal effect of this match, because it's not the student's choice or the faculty choice for this match. Afterwards, we could then instrument when students could self-select into courses after the fall of 2008. We then now are going to use a similar instrument to identify delta. And we can then compare these two after we identify delta through the variation of fraction of faculty teaching the introductory STEM courses, we can then compare those two differences to see, are we really identifying the same effect? And that could be kind of be able to test the validity of the instrument which we're trying to use. Now, unfortunately, these results are forthcoming, and hopefully we'll have them here soon. So a couple limitations to talk about with a lot of these is we're just really focusing on a lot of these transitions that occur within the first semester and even after the first year. And so it really should be important to extend this analysis to go beyond, to look at the other semesters. It becomes a little more complicated as you do so because not only you have these lagged interactions of not only do you have your experience from that first semester, but then you have this experience from the second semester and then third semester, and it's harder to kind of get a clean identification of what is the effect of the instructor, or is there a cumulative effect, or is it, if you just have one bad instructor, one good instructor, the second semester, can that overcome anything that happened that first semester? So we need to extend the analysis to additional semesters, but it just becomes a little more difficult to do. The second is more is a question to ask is this really a bad outcome? Is the fact that students enter college with the intent to major in a STEM field and then transfer to a non-STEM field, is that bad? In the sense that suppose these are just utilizing, these individuals are trying to maximize their utility. And they go to college with the intent of, maybe they were told through high school, maybe they were good at high school in science and math, that you need to become an engineer. You get to college and all of a sudden you take an economics class. And you realize, hey, economics is really fun. I'm actually very good at economics. I'm going to transfer to economics. This analysis we've done, it would show that this is a failure, that these are individuals dropping out and that's a bad outcome. when actually this actually might be ideal for and optimal for the individuals. And so this might lead to this question. So Bettinger looks at a paper of where do STEM majors transfer to? And actually, they find that they transfer to what he calls money-making majors. So economics, business, other majors that have high average earnings coming out of school. And 48% of these individuals actually transfer to business. And so they might be making optimal decisions. They realize to be in the science field, I may have to go to a lot of school, I may go to graduate school. Let's transfer to a major that I'm better suited for, and I might be able to make more money in the long run and have better labor market outcomes. And so some other extension we're going to look at is to look at what type of students with the Purdue data self-select into courses. And we want to also look at other factors that affect the decision to persist in a STEM major. And I think this is actually where the Texas School Project can provide a lot of other information that we can't do. Is right here, we're just looking at what happens in this college setting, but we really want to know what's happening beforehand. Are these individuals who enter college with the intent to major in a STEM field, are they adequately prepared? Do they look different than individuals from other schools and from other majors? And to look at kind of this idea of what does the pipeline actually look like? When do students actually enter in the pipeline? Are they entering in junior high and high school? And if so, are they adequately prepared to succeed in college? And then the question is, when do they leave? Do they actually make the decision to leave, or while they're in college, does it actually happen beforehand, but it doesn't show up until college? And so really, while we're focused a lot on these outcomes, there's really very little that we actually understand about what the pipeline is and what are some factors that lead to students leaving the pipeline. And so a lot of the future research I'm looking at is to try to identify what it is that students, or what do students look like and when they enter in, and what are the factors that contribute to them actually leaving the pipeline. That's all I have for this. Any other additional questions?